If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in power system series. So today again we will be solving 5 questions starting from question number 201 to up to question number 205. Okay, then let's try to solve these 5 questions. Okay, in question number 201, a 10 bus power system consists 4 generator buses indexed at G1 to G4, 6 load buses L1 to L6. The generator G1 is considered as slack bus. The load buses L3, L4 are the voltage control buses. Generator at bus G2 cannot supply required reactive power demand. Hence, it is operating at its maximum reactive power limit. So, you have fixed the Q limit for the generator G2. The number of nonlinear equations required for solving the load flow using NR method in polar form. So, initially, if you see your generator bus was 4, your load bus was 6. Now, if you write your PV buses, so out of these 4, one is for slack bus, so one you remove. Then minus another one, generator G2, that is operating at its maximum Q limit. So that is also converted into PQ buses, because I told you if a generator is reached it either minimum Q limit or maximum Q limit, then we fix that limit and we consider that buses, because Q is fixed now, P is already fixed, so it became PQ buses. So another one, so PV will be now 2. Now from that again 2 buses will, from the load buses, that is L1 to L6, L3, L4 are voltage control buses. So in that buses your voltage is controlled, that is V is fixed. That means they must be given with some reactive supports. So what it became some reactive power support, which is not fixed. Q is not fixed, it can take any number of Q, so that its voltage always remain fixed. So these 2 buses V is also fixed, P is already fixed, now V has become fixed, so these 2 buses now become PV buses, so plus 2. So total PV buses is, so this one is for slack, this one is for Q limit violating, this one is for, because the buses have a support, reactive power support, so it can maintain its voltage. In load buses, so PQ buses, out of 6, 2 has gone to, because in 2 buses you have fixed your voltage by giving them reactive power support, and from 1 generator buses G2, that will become PQ buses because Q is fixed. So total PQ buses is 4 plus 1, 5. Now what they are asking, number of nonlinear equations. So how many equations of P, because you are writing equations of P and Q. So how many P's equation you will have? So this is 4P you know, 5P, total 9P you know, so you can write 9 equations of P. How many Q you know? 5, so you can write 5. So total 14 nonlinear equations you will be solving. So that is your answer. Now if you come to 202, a 3 bus power system is shown in the figure where the diagonal elements are given this. The per unit value of the line reactance, these are given as. So these are line reactance, but this is admittance. So let me take it capital P, capital Q are the admittance or inverse of this one. So for 2, you can see what are connected, these 2. So if I take the admittance of this branch and this branch is capital P and capital D. So minus capital P plus minus, that is 1 by this, 1 by this, 1 by this. So I am not writing 1 by because 1 by then it will make some problem. So let me write it capital P, that is equal to minus 15. Similarly your minus 15J. So your P plus Q is equal to 15. So similarly you can write P plus capital R is equal to 3 is 7, and then Q plus R is equal to 1, that is 12. So now from these 3 equations you can solve, then it will be 17. So from here you can write P. So P will be equal to this minus this 5, Q will be equal to this minus this 10, and R will be equal to this minus this 2. So small p will be equal to minus 1 by 5J, that is 0.2J. Small q will be equal to minus 1 by 10, that is 0.1J, and R equal to 0.05J. So 0.5, 1 by 2.5. So this is your answer, 0.2, 0.1, 0.5, that is your option B. Now if you come to 203, the admittance matrix of a power system network is shown. The transmission line connected between 1 and 3 is shown in here, represented by a circuit shown, that is pi network. These 2 are the susceptance. The transmission line is removed from the surface. What is the modified bus admittance matrix? So if you remove something, that is 1, 3 is removed, so the 1, 3, 3, 3, 1, 1 element will get affected, rest will be same. So 1, 2 will be same, so you can see everywhere it is same. 2, 2, because 1, 3 were removing, so 1, 3 will be 0, so it is 0. So D is not becoming 0, so D will not be the answer obviously. So you can see now, suppose 1, 2 and 3. So what is the self admittance of this one? Because from this branch this pi will come, this pi, if you take these two, will come from this line. Also there are two shunt admit parts that will come here. From this line also there are shunt admittance that will come. So what was y33 that was connected to this shunt admittance? If you calculate, it is 20 20 40, that is 0.1. So initially it was 0.1 j. Now this is 0.05 j. Now you are removing this one. So how much will left? 0.05. So what was the 33 initially? So from that 0.05 will get reduced. So that will be, and also what is there, this branch, this is 0.05. So 1 by 0.05. So that is minus j 20. So this will also go. So what is left here? Let me write what is left here. So here it is left, this is gone. So this portion is 0.05 j, and this is, what is this? 23. What is 23 initially? 23 is j20. So admittance was j20. So j20 minus j20. So now it will be y33 will be equal to minus j20 plus 0.05 j. This is gone, this is gone. So 1 j05, 0.0505, it was 0.1. Once is 0.5, then another one is also 0.5, because total was 0.1. This came, if you add all these things, then total shunt that is connected in 33, that is 0.1. So it will be minus 19.95 j. So you can see it is in option C. D is already we have eliminated because 1 3 should be 0. 1 3 there is no branch now. So you can see. Now if you come to 204, in a total load flow solution solved by using NR method with polar coordinates, the size of the Jacobian is 100. There are 20 PV buses in addition to PQ buses and slack buses. Total number of buses. So PV buses is 20. PQ I don't know, suppose X. Slack is 1. So total Jacobian size. So 100 into 100 means 100 equation, 100 unknown. The first one is equation row. So you can see rows come from this P and Q. Here I have shown you this. Because what was the Jacobian size? I told you we write it is delta P delta Q format is equal to Jacobian into delta 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 V. This was the format. So this is the number of equations, this is the number of unknowns. So number of equations is P and Q. So total number of equation is 100. From here you can see what are the number of equation. P is 20 plus X, 20 plus X, Q is only X. So this is the number of equation, that is equal to 100. Or X is equal to 40, 2x equal to 80 or X equal to 40. So once you have X equal to 40, so total bus 20 plus 40 plus 1, that is 61. So this is your answer. The figure shows per phase representation of a phase shifting transformer connected between bus 1 and 2, where alpha or A is the, or you can say this is alpha or A, whatever, is a complex number with non-zero real and imaginary part. So it has both real part and imaginary part. So it had mode, magnitudes and angle also, because it is a complex number, non-zero real and imaginary is also there. It is not that only 1:2. It is 1:2 at an angle 30. So ratio is also multiplied, so it will, voltage also will be getting 2 times, angle will also change 30 degrees. So that is the meaning of alpha becoming a complex number. So its magnitude also get normally transformer, what we do, 1:3, that means we multiply the voltage by 3 times. But here angle will be also added, because it will be 3 angle 10, 3 angle 20 something. So angle will all be also added. So that is the phase shifting transformer. For the given circuit, Y bus and admittance bus and bus impedance matrix respectively, then each of these are 2 cross 2. Obviously it will be 2 cross 2 buses. Which one of the following? Both are symmetric, unsymmetric. Now this can be proved. I am not deriving this one, but I think you know this one. Suppose this is your YT, and then you have a transformer. This is your bus 1, bus 2, and this is 1:2 alpha. Now it can be derived if you find your Y bus for this one. Simple equation by taking a virtual bus here Vx, then this ratio is 1 into this, V2 is equal to Vx into alpha. So by doing this substitution it can be proved. I think you know also. So this divided by alpha, and this is minus Yt by alpha star. Yt is this one, and this is Yt by. So this is the format that comes in between this one to this one. So if you see now this bus, because if alpha is not a complex number, simple number, then 1 conjugate is also, star means conjugate. Conjugate of 1 is also 1, conjugate of 2 is also 2, but conjugate of 2 angle 20 is not 2. This is 2 angle minus 20. So conjugates are not equal. So that's why it is not symmetric. What is the symmetric matrix? Symmetric matrix means this and this should be same. Y12 is equal to Y21. That was the meaning of symmetric matrix. It would be symmetric if alpha is a real number. If alpha is a complex number or it has some angle part or imaginary part, then star will change it. So that's why in this case y is not symmetric. Since y is not symmetric, z is nothing but y inverse. So z will also not be symmetric matrix. So yz both are not symmetric. That is your option D. Both y v are not unsymmetric. If you like the video, then press the like button and please give your valuable comments in the comment section.